Hello and welcome back. In part 6 we created all these sheet metal components geometry except for this last component, and the reason for that is we do not yet have the necessary information to do so. We need to use surrounding geometry as reference, and by that I mean we need to have the two ring and this deflector created before we can build this last component. So the goal of this part will be to create these three components, and what we need to do first is to create a circular opening where the two rings will sit using this red cycle. Before we move forward, let me show you how I change the color of the cycle to red. So select the master sketch and hit edit profile. This cycle should have a diameter of 815. To change the color, select the cycle, and in the command bar you have this button line color. So click on the button and there you can select any color you want, and in my case the red color. You can also change the line font or the line thickness. I did the same for the deflector. Then you hit finish. Maybe in your case the color will not change. This is because you have two things more to do. The first thing is to right click on the sketch and select multicolor sketch display, and the second thing is to move to this inspect tab and turn off relationship colors. If I turn it on, you see the color is just black and blue, but if I turn this off, you see I can see the red geometry on my sketch. Okay, so this is how I did it. Okay, back on track. There is two ways to create the circular opening. The first way is to jump inside each part and make sure that your assembly level components and geometry are visible by pressing Ctrl plus Q on your keyboard. Then locate this whole command group, and as you can see the command is in two parts. So we make sure that we select the bottom part of the command so that we can access more options. And what we are going to use is the cut tool. The cut will be created using a sketch from a coincident plane. So we select the ZX plane, and we can either redraw this cycle because we know the diameter, but this will be silly because we did it once. What I want to show you now is another way to copy geometry from one sketch to another. The first way, as we did for these two sketches, was to use the copy sketch from the assembly to the part. We cannot do the same this time because there is too much geometry in the master sketch to deal with, and we only need this red cycle. The second way is to use this include tool, and this will copy only selected geometry, while the copy sketch tool copied the entire sketch. So we will use this include tool, and we are going to select only the red cycle. And if we again press Ctrl plus Q on the keyboard, you see we are left with this cycle inside our sketch, and we'll hit close sketch to return to the cut command. As you can see, on the left side of our cycle there is a red arrow. This arrow defines the site where the material is cut from the part. And if I move the cursor on the opposite side, the material will be cut on the opposite side. If I move the cursor so that the arrow becomes a double-sided arrow, the material is cut from both sides through all. So we make sure that we have this double-sided red arrow and click to perform the cut, and then hit finish. Okay, so now we have the first component cut, and we will have to repeat these steps for the remaining components. And obviously this is not the best way to do this task. So we are just going to delete this cutout, and we are going to go back to the assembly, and now I will show you a much better and efficient way to do this. The most efficient way to create this cutout in all the parts is to use an assembly based feature. And to access assembly based features, move to this features tab, and from there we can access the same cutout feature we use inside this part. So you will select the cutout feature, and there we have two options. We can either create assembly features. The cutout will be created only on the top assembly, and the parts will not be impacted. That means that inside the assembly you will see the cutout, but inside the part you will not see the cutout. Or you can create assembly driven part feature. That means the cutout will be created inside the assembly and propagated inside each of these parts, and this is what we want. We select OK. Now we make sure that in the create from option we have the select from sketch active, because we can select the cycle directly from the master sketch in this case, and then we will right click to accept. Now we can cut either in this side or on the other side. We will make sure that we have this cut through all active, and now you can see there is the red arrow we had previously. We again make sure that the arrow becomes a double-sided arrow, so we will cut in both directions, and we will click to accept. Now we have to select the part that will be impacted from the cut. As you can see, some parts are already pre-selected, and this is what we want. So we will just right click, and Solid Edge will compute the cut, and as you can see, all the parts are cut at the same time, and you just have to finish and then cancel. Now if we take a look inside this part, so edit in place, you can see there is a cut feature added inside the part. Okay, the same will apply for this part, this one too. Okay, so as you can see, this is a very efficient way to perform the same operation in several parts in one shot. In the assembly tree we have this new group, assembly driven part features, and inside you can find the cutout we just created. So if you want to edit the cutout, here is where we will find it, and we will be able to edit the profile or edit the feature. Now we can proceed and create the two rings that will be located in this cutout. We will start with this first one. As we did when we create the sheet metal components, we will create a specific template for our non-sheet metal component. To do that, we will move again to this application button and select open, and we are going to use a copy of the isopart template to create our custom template. So we select the isopart template and open, then right away into the application button select save as, and we will rename it spiral casing underscore part, and then save. Now we go to the properties material table, and then we will define steel structural as the material, and then apply to the model and save. You can define more property if you want, but for this tutorial this is all we need. So we will just close the window. Now using the radial menu, we'll create a new part in place, and we will use the spiral casing part template. We will make sure that we will leave the assembly environment and enter the part environment when the part we've created. So we will activate this option and then right click, and we will save the new component as R1, meaning ring 1, and it's save. So as you can see, the part is created and we are in the part environment. We will do a Ctrl Q to show assembly components. To create the geometry of the ring, we are going to use the Extrude tool, and the plane we are going to use to create our sketch will be a parallel plane, and the ZX plane will be used as the reference plane. To position the parallel plane, we need to use the endpoint of this line, but right now we cannot easily select it because there are these components on the way. So we are going to hide them, and now we can select the endpoint and position the plane. We are going to make sure the sketch is oriented normal to the plane, so we can use the include tool to select the red cycle. And now if we do again a Ctrl Q, you can see the cycle is copied in our sketch. Now we can just close the sketch to return to the extrude tool. To finish the extrude, we have to define the distance, and that will be 50 millimeters. And we make sure that the extrusion is positioned on the right side, so this side, and click to finish. Ctrl Q again to show the assembly components, and you can see how the ring is positioned in the assembly. Okay, now we will remove material from this part to create this internal shape using the Revolve cut. So we will launch the Revolve cut tool and Ctrl Q to hide assembly level object, and we select the YZ plane as the coincident plane. Make sure we are looking normal to the sketch plane, and we can now draw the profile to be cut. As every time we enter the sketch environment, the line tool is already active. We are going to start with an horizontal line, and we're going to make sure that the first point of the line is right on this edge of the part. If you cannot select the edge, make sure that you have this on element active on the IntelliSketch. So now we create the first line, then an vertical line and horizontal line again, and we will move down until we reach the middle point of the edge again, and then the center point of this edge, and we can now close the sketch. The next step is to add the diameter dimensions. So we will have this 710 and this 690. So we will use this Symetric diameter tool, and the first input is the dimension origin element. So we select this line, and the next input the measurement element, so this line, and we have our first dimension created, and we'll change the value to 710. Now we will right click to reset the tool and select this line as the origin element again, then this endpoint or this line as the measurement element, then click to create the dimension and change the value to 690, then enter. Okay, to finish our profile, what we have to do is to enter a length dimension, so the length of this line, and we will input 35. Okay, we make sure that the sketch is fully defined, so we move to this inspect tab and activate the relationship colors, and as you can see, everything is black so that the sketch is fully defined. Okay, if we close the sketch, we'll have this profile error assistant dialog box. Revolve feature must have an axis of revolution. So we will close the box, and what we need to do is to use this tool, axis of revolution, to define the axis for our revolve cut. So we select the tool and we will select this line, and now we can close the sketch. And to finish, we have to define a angle for the cut. We want to cut 360 degrees, so we will use this option, Revolve 360, and as you can see, the part is cut as we want it, and then finish, cancel. Now we will create these threaded holes, and there are 20 holes M27 on a 765 diameter, and the thread depth is 25 millimeters and the drill depth 32. The first hole is spaced 9 degrees from the x-axis. To create the hole, the tool is obviously the hole tool, and we need to select the coincident plane the hole will start from. So we select this face, and we will make sure we are normal to the plane, and we have the whole cycle command already active. So what we just have to do is to select all options so that we can size the hole we want to create. We want a threaded hole, so on the type list we will select threaded, and we make sure that under the thread we are selecting the right hole. So we look for M27 by 2, and the thread depth will be 25 millimeters as I said before. And to define the drill depth, we will choose this finite extent, and we will define the value as 35. We make sure that the bottom is a V bottom angle style, and the angle is 118 degree, and we make sure that the depth is measured as shown, and then hit OK. Now we have to position the hole on the part, so we will just place it somewhere like that. And to fully define the position of the hole, we have to first create a cycle from the center, and the diameter will be 765 millimeter. Escape. Now we make sure, using the connect tool, that the center of this hole is on the side, the big cycle, and then we will create a line from the origin to the center of the hole. And to finish, all we have to do is to create an angular dimension from the x-axis to this line and input 9 degrees as the value. As you can see, the hole is fully positioned. We will make this line and this cycle construction using this construction tool. This is not really necessary, but we will do it anyway. Then close sketch, and we have to define the side where the material will be cut from, so it will be on this side, and right click to finish, then cancel. Now using the pattern tool, we will duplicate this hole so that we have 20 holes. So the first step is to select the feature we want to duplicate. So it will be this hole. Then we will right click to accept the selection. Now a plane from which we will define how the pattern will be created. We will use this coincident plane option and we select this face. Now we can either create a circular pattern or a rectangular pattern. The circular pattern is already active and this is what we want. So we make sure we are looking normal from the sketch plane, and we will draw a cycle from the origin to the center of our threaded hole. Now we have to define the number of occurrences we want in the pattern. 20 is already entered, so I will just keep the value and I will click to create the pattern cycle. As you can see, there is a preview of our holes as they will be created. So close sketch and let Solid Edge compute and display the whole pattern, and right click to finish. And now, as you can see, holes are created and we are done with this part. So we'll close and return to the assembly, and we are going to create the second ring. So radial menu, create in place, make sure we will be in edit in place mode, and right click to save the part. It will be named R2 and then save. Ctrl Q to show assembly components, and again we are going to use the extrude tool and create from the sketch on a parallel plane as we did for the first one. So we select this plane, and again we will hide these two components so we can reference the endpoint of one of these two lines. And now the plane is positioned. We will use this include tool again, select this big cycle, and this time we also select the small inner diameter of the first ring. So we have two cycles on our sketch, and the reason for that is if we take a look on the 2D drawing, these two diameters are equals. So that is the design intent. If later we decide to change this value, the second one will be updated as well. This is why we are doing the include. Okay, now we will close the sketch. Ctrl Q to show assembly components. We are going to input the distance of the extrude as 35 millimeters. 35 millimeters, and make sure that the extrude will be created on the right side, and we click to finish and right click to finish. We will cancel, close and return to the assembly, and we are going to add a new part, and this part will be D1 as deflector 1, then save, and again we jump inside the part environment. We will create the extrude from the XZ plane as a coincident plane, and we will make sure that we clear the way so that we can easily include the deflector geometry in our sketch. So select this line, this arc, this line, and this last one, and we can do Ctrl Q to make sure that we select the right geometry, and it is. Then Ctrl Q to show back the assembly object again. Now close sketch, and this time we want the extent of the extrusion to be both sides. So we are going to activate this symmetric extend option, And now as you can see, the extrude extends from both sides, and we are going to select the endpoint of this line to define the distance and finish, then cancel. Now you can see how the deflector is positioned within the assembly. We can show all these components and it close and return to the assembly. Okay, now that we have these 3 new components added, we can now proceed and create the geometry for this last sheet metal components, and we will do that in the next part of this tutorial. So thanks again for watching, and see you on the next part.